Hello everyone. How are you? How are you? How are you? Let's see. Share. This work. Share. Copy link. Let's get people here. Okay, cool. I've done that. I like to pop out the chat. Do I want to pop out the chat? Yeah, I want to pop out the chat so that I don't have to look at. I do not have to look at myself all the time as I stream. Everyone. So, what are we doing today? So, over the past couple of sessions, we've been working on a Bluetooth application, and the Bluetooth application that we've been working on is basically, I'm just gonna copy links for this, and we are live. Notes here. Okay, so we've spent the last couple of days building a Bluetooth application, and the Bluetooth application that we've been building is this basically temperature and light service that you can control over Bluetooth. So you can read the temperature over Bluetooth, and as we go along, I'll probably add an LED control for the board so that we can make the board blink or not. And this should actually come when I have a USB cable for the board, so I can show it in the screen. However, one of the few things that you start encountering is how to do over-the-air updates. And when you do so, over-the-air updates is basically when you can send. It's almost like pretending like firmware is normal software, and then what you want to do is send firmware over the air, over a network, to some device in a remote location. So say you have a device that's located on top of a cell tower, and this device does some stuff, and every other 6 months you have an update from your firmware team, and they've gotten a few more updates, and they're using the hardware better or the batteries better, and someone has to drive by and update the thing. In traditional scenarios, you would have a technician come to the place, and they would have to climb up, and then they would go to the thing, and they would reset it, and then they would probably plug it into some sort of programming machine or programming terminal, and then they would provision this new software and such and so on and so forth. However, this becomes very tedious and very expensive because people are expensive, and usually the edge, when you're using embedded, the edge is somewhere that is very far. So the need to send firmware updates over the air becomes really important, over the air being network, and you can do this in a number of ways. In order to do that, you need to now start tackling problems that are sort of your device has something that's called a bootloader. Your bootloader is the first application that I actually have done a sample of a bootloader here. So let's GitHub, that's probably Zach, and then STM. Yeah, so I have done a bootloader over here. There's a bootloader app on this repository. And if you come to the core, and then if you come to the source, you'll find the code itself, and if you follow the history, I did this a year ago or something, but I did this a year ago or something. And what you need to see is, what did we do with ChatGPT a year ago? Oh yeah, I was finding out where my memory maps are right. Cool. So once you have built, basically a bootloader is a fast application that is run whenever you're running an embedded application. The thing that touches the metal and then decides what happens. And usually, if you have, let's say, like a development board like a STM32F4, it comes with a bootloader from factory, which is in this ROM section. I want to open a manual. So let's open a manual. Okay. Anyways. It comes with a bootloader from factory, reference manual, ROM. I'm gonna jump into the code just now, so this is just me setting up. That's not what I want. I want space and then ROM. Nope. Yep. Let's see. It's RAM and ROM. Basically, what I'm saying is, your device comes with the read-only memory section, and this read-only memory section is composed of your bootloader, which is the first application that runs. Let's see, what is a bootloader? Bootloader, yep, nice. So see. A bootloader is a computer system a program that is responsible for booting a computer and pointing it to the right start place. So with firmware, you don't have an operating system, or if you have an RTOS, bootloader will run and then it will point to your application. Your application is a different bit of software, so it will just point to it. In practice, what really happens is your bootloader will point at the entry function memory location of your application. And the way you do it is you make a bootloader that points to this specific memory location. Okay, and then you make an application that is loaded to a specific memory location. So let me see if I can find this code somewhere quickly. So if we go here, we will see that this is verifying, this is writing, this is I want to handle get help, no, I want to handle MCU chip ID, no, get command, no. Let's just go straight to, that's the address, it's verified, it's verifying that the address is right, and then execute flash arrays, handle flash arrays command. You see, it writes to a memory location, which this is when it has gotten the software that your firmware. Now it will write your firmware to a certain location, and then you have something like bootloader jump to user app. When you're jumping to user app, you're just jumping to the entry points memory location. The entry point of your user application, you jump to that. An entry point is a function, the function that starts, basically main. You put main somewhere, and then another program will start up the device and then point the execution registers to where your main is. That's what a bootloader is, regardless. So anyways, let's jump into some code and see if we can actually implement this, or rather, basically. So the way we would build this up in Zephyr is we would use, or one of the ways of building this app in Zephyr is by using a bootloader called MCUboot. MCUboot is a bootloader from Apache Newt, and there should be an MCUboot link somewhere here. Yes, MCUboot. MCUboot, yeah, here it is. Hopefully. So yeah, it's a secure bootloader for 32-bit microcontrollers. So this is just another bootloader. So in order for us to do over-the-air updates, the bootloader that we're going to be using in Zephyr is MCUboot, number one. So most of the stuff that we need to do is to realize how to install MCUboot, the requirements of MCUboot, and then how to run it with MCUboot. There's a version in Zephyr called using MCUboot with sysbuild, and this one seems to really work. My issue is whenever I use this option, I end up getting stuck because the app I never actually succeed in flashing the MCUboot application, the application that I built with MCUboot. But however, the thing that I realized in my research is this board that I'm using, the NRF 52840DK, has instructions on how we can basically use MCUboot because this board comes with how do I say this? Yeah, that doesn't matter. So this board comes with, it doesn't have an onboard debugger. Because it doesn't have an onboard debugger, there's a number of ways of configuring this board so that we can write firmware to it. And one of the ways of writing firmware, the way that we have been doing previously is by packaging the firmware using NRF util, and then we use the onboard read-only bootloader, and then once we have that bootloader, we package the application into a zip, and then we write it. So this is the formula that we've been using. So it's here. We build the application, we package it as such, and then let's do that. Let's quickly do that. So first of all, we need to put it in bootloader mode. Cool. And then let's do all of this, but for the Blinky application. So yeah, cool. Where do I have? Yeah. So I'll just do that. Control R, activate. Let's activate the Python thing there, and then the samples, CDs of samples, basic Blinky. Okay, cool. And then let's do what the thing was saying. We need to first of all build this for this board. West, ls clear. Okay. Put ref build. Yeah, I was just making sure I didn't have some overlay here that would make it not work. Okay, so let's west build -p always -b nrf 52840 dongle nrf 52840. Let's build a Blinky sample. Okay, cool. I'm gonna build a Blinky sample. So this is the old way. This is the way we've been doing it so far, and I want us to explore this, and then we'll jump into the MCUboot way, and then we will show you. We'll basically, once we start building up into MCUboot, we will see how we can achieve firmware over the air updates with BLE. But let's see what we're doing now. So there's that, and then we need this command. So I'll just copy it. Why not? Makes more sense, and it's in there. Build the process of the hex. Okay. I will close you because you keep confusing me. Let's jump into the terminal. Let's do that. Let's Control V, and then let's package it. It will package it. And then first of all, let's note you're not providing a signature key, which means the DFU files will not be signed and are vulnerable to tampering. So remember this part in our bootloader where the application does CRC verification. This guy, where are you? CRC verification, please quickly. So let's go quickly. Basically, we check the checksum of the packages that we get, and that makes sure we know that it is a checksum that is how do I say that? We check that the firmware that we were supposed to be sent is the same firmware that we are getting. Okay, cool. So that's one type of check, which is this actually, you sent me this file, is this the file you actually said? Is this the file I actually have? That's all the check. But because we haven't signed this, anyone can send a valid package and it would work. So we need to add security on that. But before we do that, let us handle the actual let's use this, and then let's actually do that so that we can flash it. Yeah. Boom. So there's that device programmed, and I want to jump here perhaps, and I want to run screen so that you can see what is happening. I can't unplug it and show it to you because it will go off. It gets its power from USB. But what we're seeing is we've managed to flash some firmware, and that firmware has got into the device. But this firmware is insecure. The meaning of that is that it's not signed. So anyone, as long as they build valid firmware, they can take a copy of our firmware, add some malicious data in there or malicious instructions, and sign it back to this, and it would still work. So the onboard bootloader would just take this and work with it as it is. So now that introduces us to the new change, how to use MCUboot, and I have some notes here. So MCUboot is a bootloader that allows us to do basically red-green updates. We provide two slots, a primary slot and a secondary slot, and the primary slot holds the version of the firmware that we're running, and then the secondary slot holds the version of the firmware that we want to update to. And then using these things called items called trailer flags. Trailer flags are image okay, copy done, boot pending. The device can be in various states so that when we reboot, it goes into something else. Let's attempt this. Let's attempt an MCUboot application, and then let's attempt building Blinky with MCUboot, and then after we get it done with MCUboot and provision it with MCUboot, we will now go back and build our own application. And because you're starting from what we're doing is basically we're starting from known knowns, and then we're going towards known unknowns. Okay, so let's check out that the samples in Zephyr will work with this properly. That's perfect. So let's look at option 2. It is also possible to use the MCUboot bootloader with this board to flash Zephyr applications. You do need to do a one-time setup to build and flash MCUboot on your application. Remember, our bootloader is also an application, so we need to flash the bootloader, and then we flash the bootloader once, and then on top of that, we never have to flash the bootloader again. Basically, we're in this mode where we can now start to receive updates of using a utility like MCU Manager. Basically, bootloader, you flash MCUboot at the factory, and then you flash version 1 of your software at the factory, and then the device goes to the edge. Okay, and then you get an update of your software, you send the device, you send the update by some over the air mechanism. You send the update to the device, and you don't have to rewrite your bootloader that was on top. That was the base. What you have to do is rewrite just the resident application. So let's go through this and actually install MCUboot. So reset the board into Nordic bootloader, which means press the reset button. 1, 2. That is in. And then compile MCUboot as a Zephyr application, which I think I have already done. It's here. Or is it here? Yeah. ls MCU build and MCUboot. So I do have a Zephyr application in here, and if you are familiar with Zephyr builds, you know in the Zephyr folder there's going to be hexes and elves and bins that we can use. Okay, cool. And then flash it once into the bootloader. So let's first do this, and then maybe do I have an MCUboot.zip? Yeah, I do have it. So package just the same way we did with our own application, and then now we need to flash it into the application, into our device. So that's the first thing. Excuse me. Amazing. I wonder if this gives us any logs. Does this give us any logs? Just if I just run that. Okay, cool. UDC and RF, we do get some logs. So now let's go back and build MCUboot. So they give you, the first thing you need to do is to get a MCU Manager application. Let's go and look at what MCU Manager is. MCU Manager is, can I see MCU MGR? What are you? Is there a link I can click? Okay, quickly. So the management subsystem allows remote management of Zephyr-enabled devices. The following management operations are available via MCU Manager: image management, file system management, operating system management, settings, configuration manager, shell management, statistic management, Zephyr management, over the following transports. Now you see what we are getting into. You can do this, you can do MCU management using MCU Manager. We'll get to that. You can do MCU Manager over Bluetooth. You can do MCU Manager over serial UART, and then you can do MCU management over UDP. So IP, basically you can send software updates to your devices in the edge via either Bluetooth, UART, or UDP, basically IP networks. And MCU Manager is this tool that is a management library for 32-bit MCUs. So cool. Most of today's work is already done. We're just going to be using work. So let's look at what we need to do to use MCU Manager. We've installed NRF util. We're already using it. We've installed it. MCU Manager, we've installed it. And we've installed it and built it. So next, do a one-time setup flash to flash MCUboot. We've done that. Cool. You can now flash a Zephyr application to the board using MCUboot serial recovery mode. We will use the SMP server. I won't use that one because it doesn't have an SMP server is a simple management protocol server, which you can use to do basically we are installing an app on the device that can do applications such as file system management, image management, operating system management, statistics management, and all of this on another application. What I want us to do is to just put in a normal application. So, and if indeed that is what we want to do, if we go down, we can find a way here. There is a way. They provide a way. Okay, so we can't build a basic Blinky sample with MCUboot, or rather, we can't build it with MCUboot and then we can start signing it. So let's Control Shift V, and then let's look at this. Build Blinky. I don't really need to do that. I don't need to specify this. I don't need to specify that. I can just build it straight because I'm in here. So let's see. Okay, cool. So CMake warning at that. Neither CMake MCUboot generate unsigned image or config MCUboot signature key file are set. The generated build will not be bootable by MCU unless it is signed manually and externally. So this begins to show you the secure part of our firmware over the air updates. So the developer can build it, but MCUboot will not accept this application unless we sign it. So now let's go back. Let's do the signing. So we've built it. Let's do the signing. So this is build Blinky. So let's do that. I need to go to the MCUboot folder there, but that's fine. Control Shift V. So okay, so this is fine. I need to be here. I need to be build Blinky. So let's do that, and then here we need to go to the end, and then we need to get to the home directory, then we need to go to the Zephyr project, then we need to go to MCUboot, and then from MCUboot we need what? We need the root RS 2048 PM. So let us sign this. No such build directory as home. Build samples basic Blinky build Blinky ls build. So it's fine, it's fine. Can I do that? No, that's not what I want. This is Blinky signed. Okay, we've signed the build now. So West sign using image tool has been deprecated. We'll come back to that later. Okay, cool. So we've now signed the build. Now let's go and do this. We need to run an MCU manager command. What does this do? It goes over serial, and then it uploads that image Blinky. Okay, boom. It's not busy. Ooh, you know what? So let's see. Boot into MCUboot. Recover is special serial recovery mode by plugging the board start by plugging the boot with the SW1 button pressed. So I need to go into this is why the other day when we were looking at the NRF 52840, we were also exploring the wake up sources. So if you want to do this completely over the air, you do need to reboot into MCUboot so that you can put in the new firmware. And let's do that. And it appears right now the way to do that is to do this, press the SW1 and then let go. And then I think even with that there should be a new, yeah, let's do that. Yes, there's an MCU device there. Oh, nice. So now it's been booted into. Now let's do that. We're in MCUboot. Let's boom. We are flashing an image. Hopefully it blinks. So it won't blink now because once we've flashed, we still need to reboot the application. So we need to. You remember those wake up sources? We need to reset the application so that it can go into MCUboot mode, and then we need to reset the application so that it can go into MCUboot. And then after we've installed, look at the instructions here. After we've flashed the application, we need to reset the application again. You see, so these are things you want to be able to do either from the how do I say this? You want to be able to do this from the network so that you don't have to go to the device, press the button, and then copy the software over and such and so on. So let's do that. Let's copy that, and then let's connection of a serial connection string is that, and then we want to do our reset. Boom. No way. There you go. We have secure firmware updates over the air. Signed. We've signed. We've made an application. We've signed it. We've loaded it. So let's try this with our own application and see if does this actually work. So we want to go back here, and then we want to go back into applications. Okay, clear. ls cd custom ls cd Zephyr custom BLE service. Okay, so this is what we've been working on. Clear, come on. And this is just the code we've been working on the past few days. There's a source folder, there's a BLE service, there's a BLE service, there's a temperature service. So if we quit and then we go back here again, so we want to do this. This is not special. The only special thing here is this. So we just want to build, we don't want a directory, we just want to pass that configuration MCUboot. So let's build it. If we see an MCUboot warning, we know that this has worked. Yes, so there is an MCUboot warning about having an unsigned application. Amazing. So this is just our normal application that we're building that has the temperature and light control. So, but now we're building it for MCUboot. Yeah, I can't reset it with that. So I would have to make, if I had firmware and I wanted to reset for, that, I would have to, I'm thinking out loud about what I would have to do so that I can reset this application straight into MCUboot mode without building it. So first of all, let's cut build Zephyr.config, and then let's grep MCUboot. Let's see. Oh wow, so MCUboot has been configured. Zephyr has a module, there's a signature, keys there, but we're going to sign it now. There's that. Cool. So yeah, MCUboot has been set up by that build. That is enough. So we now come back and we want to do the signing. Let's see, can we just go back up? I should make no, that's upload. Image tool signing. So this is T and E. Thunder. Okay, cool. So that's signed. Let's see. I need to go back and. Okay, so we've rebooted into that. We've rebooted into MCUboot, and now let's go back and do the. Image upload. So this is Thunder. It is uploading. Wow, it is uploading. So first of all, let's check our BLE. There's no Campaign Light applications, and then also if we do come to our monitor here, we will find that the monitor was closed. Yeah, the screen was terminated because we disconnected. Okay, cool. So let's build that. So we've signed it. It's secure, and I need to find out what should be instead of West sign. What it should be instead of West sign. I just need to know which one it should be. Do I have another West somewhere? Okay, West help. SDK. West sign. So, but they're saying that's deprecated. West sign too. But if that is deprecated, then what do we use for? Anyways, we will know later. So we have, remember, we now have our application built using MCUboot and signed. So what we need to do is we need to now provision. Let's provision it. Contype. No, we need to now we need to now reset. We've provisioned the application, now we need to reset it. So let's reset. Amazing. I do not have any lights, but if I do here, we should have our temperature. There you go. There you go. And see, and you can see the results from yesterday. So the temperature, the sensor module is reading, and as it is collecting the information, it is putting it in the queue, and then it is then validating the queue as the queue is growing too old. So what have we sort of covered today? What MCUboot is, okay, and what MCU Manager is. So MCUboot is a bootloader that has all these security features. So basically you have to build a bootloader that expects its image to be signed, expects communication with a manager, expects all of these things, and that is what MCUboot is. It's this bootloader that has all these features for securing the application, okay. And then we have this terminal program on our computer. It could be I wonder first of all, this MCU Manager is this program on our computer, or it could be on a phone, or it could be on wherever. It just implements the SMP, simple what does SMP mean again? Simple, oh my word, SMP server, simple management protocol. So it's an app. So MCU Manager implements simple management protocol. If you can implement the SMP protocol, regardless of whichever device you have, you can use MCUboot to disperse updates to your applications. So we're now using. So there's a bit of cheating. Here, if anyone has noticed. We are using the serial connection. That's kind of cheating. The reason that's kind of cheating is because the serial connection is a wired connection between my computer and the device right now. And I wonder if MCU Manager will let us, let's see, command line tool that handles commands. Let's see if it has any supported MCU Manager of a Bluetooth, the Bluetooth device. MGR BLE. Yeah, so there you go. That's what I wanted to see. The command line. Here's the command line. So MCU Manager allows us to upload a new image using BLE. You can use BLE. You can use UDP, and you can use serial. We've already used serial. So, and I've not implemented UDP yet. I want to see if my old laptop actually implements BLE and actually lets us upload some firmware. So I will remove this and I'll put it back in bootloader mode, MCU bootloader mode. And I think there's a terminal here. If we do this, we will see that there's nothing. Okay, cool. And I think the only thing I want to do is run the last command, because right now, and then in here I want to do BLE. I might have to change something, but let's see. I think I made some notes here on how to do that based on my research earlier. So peer ID, HCI1, peer ID, image list. So there's this one, but I don't know my peer ID. BLE peer ID. So I can just reboot first of all to the normal one. I'll reboot. I'm rebooting into our application. Just like that. Let's see if it's there. Yeah, cool. I've rebooted into our application. That's cool. Temp and light. Connect. So I'm going to see if I can copy the... Can I get... No. Can I get the peer ID somewhere in here? If I can't get the peer ID, then we can likely... Oh my word. If I can't get the peer ID, let me reboot it again. Sorry. I'm trying to see if I can get the peer ID. Because that's all we need. Temp and light. And get connected. Wow. More details about this. It's quite odd. Oh wow. Oh wow. Oh wow. I can't see quite a lot. I can't see quite a lot. So what do I want to see? What do I want to see? I want to see the peer ID somewhere. Oh, so I suspect that 1031 dash 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 is going to be my peer ID. So let's So I do not know how to 2990 2990. We can try that. I had it on my notes here. I should have tried it before the thing. Let's see here. Constraint. Let's see here. Peer ID. And then I want to do something. I don't need to provide about probably, so I just need to do a peer ID. And then let's see here. We do need to go into. So there's I'll take a screenshot so in case, because I might connect, and then if I do connect, I'll just take a screenshot because I'm gonna disconnect it and it's gonna go off. My card is complaining, so that's off already. So let's look at this thing. So let's look at this thing. Let's try 2990. So 2990. So this is 10.18. No, 10.30.18.2990 over BLE. Reset, let's see. Can we upload? Yeah, can we upload the same over BLE? Over BLE, that's fine. It cannot reset because it's in there. Peer ID equals 10.30.18.2990. Using okay, cool, but the concept applies, but I should just struggle and get it working now. Should be a name. What did we say? How are we gonna do it? Okay, cool. Let's just look at that. I don't want to use a con type serial. Oh! Con type BLE. If we do that, what happened there? Is it down? Am I resetting? Am I resetting? Am I resetting? No, I'm trying to upload. Cannot down. Cannot down. Why is it? Why can it not down? It is off. Why is it? Can't. Okay, cool. So let's just try and go with the way it is here. BLE constring. Yeah. CTRL name HCI. Wow, no, that sounds long. That looks long. Wrong. HCI name HCIO. Now it becomes the debugging part of our thing. Just let's see. CTLR. That's actually my problem. I don't need a HCI, but I do. Can't type equals with me. That's the problem. This is why I didn't want to do this. I don't think I have enough. Don't do that. I don't think I have Bluetooth. I don't think I can use BLE on my old Linux machine. Don't be an open bag. Don't be an open Bluetooth bag. Please be closed. Please be closed. Please be closed. Is this closed? Oh, come on, status. Linux in progress. Yeah. Invalid. Fix released. Unknown. But I'm already on the newest one. Okay, cool. I see. So, because we've discovered we have a bug or some issue with our Bluetooth thing. So, basically, we can't do updates over BLE because of that. However, we have explored how to load up a secure bootloader, how to sign our images, and how to send them over the network. Right now, we're using serial. But if we had Bluetooth working, we could have sent them over Bluetooth, or we could have sent them over something like IP. Thank you so much for showing up today and hanging out with me. And that was just a good session on OTA updates, the kinds of problems you're going to encounter, and actually how simple and easy it is. This basically doesn't need any change in our code at all. There's no change. This is one of the reasons I like Zephyr. You see, every time I had to use this bootloader, wherever you move it, this bootloader requires the clock settings for the bootloader application and clock settings for the user application to be the same, and the FPU and the register initializations to be the same. Otherwise, this bootloader will just not jump to the new application. So, and then you have to do all of this. If you've done a bootloader, you know that your interrupts, there's a point at which you need to disable your interrupts, but then there's a point at which your interrupts also block you, and then you can't move from bootloader to the user application. But with Zephyr now, we basically don't need to change. There's no push today. There's no push. The only thing we can push perhaps is so that this does not, so that we don't have to. There's this West build. This config bootloader MCUboot. This is the only thing that we would have to put. We can't put in the code, and vim, yeah, and then project configuration, and then we need to yeah, there you go. I'm gonna do secure folder, and I'm gonna leave it commented out. Config what is it? Let's copy it in. NRF, what is it? Just give me that thing. Config bootloader MCUboot. Config bootloader MCUboot. There you go, equals 1. That adds bootloader, adds a bootloader to the application, and then we can use external things to manage this bootloader and use it in practice. Git. That is so small, I'm not even gonna make a branch. Git add ph.conf rm-rf done sign, and then git commit -m add MCUboot for secure folder. Amazing. Git push. Tomorrow when I stream again, I'll have found a way either from the phone, so that we can use firmware updates over the phone, or I'll have found a way of fixing it so that I can use my laptop to do firmware updates. Thank you so much for hanging out with me today. That has been really amazing. It's been quite chill, and they're getting so much better now. I'm amazed at what we can do now. This has been a very short sequence. Anyways, thank you so much for hanging out. It's been cool. If anyone has any questions on anything, basically, do ask, and shoot out some questions, shoot out some goods, and then tomorrow we should be handling. I'm not so sure what we're doing tomorrow, but I'll schedule the live, and you can see it from Git and everything. And yeah, thank you so much. Cheers. Awesome hanging out. Awesome seeing you guys. Thank you.